If you want to see someone who doesn't know what they're doing not fix a motherboard, that's what this crap is. This is the 5th motherboard I bought, but the 4th faulty 3rd gen Intel motherboard. I got it on the cheap because it was faulty and thought it might be an easier fix than the one I wasn't getting anywhere with. This is an ASRock H77M. The fault. The guy said it was stuck in boot loops, but it kind of starts, it's just that it doesn't boot. I pulled the RAM and started it, but there's no beep codes. Beep codes tell you if there's something happening when there's no display, like it's partially booting, so it's best to always fit a speaker. Because there's no display, I fitted a video card and the fan kind of moves a bit. I guess that's his interpretation of boot loops. I don't think it's power to the start circuits because the fan spins, but we'll check the battery anyway. This battery has 2.8 volts off the board, so it's okay. You're mainly looking if it's being pulled down by a short or dead totally. Next we'll check current draw to the battery. You want a tiny bit of current draw so you know the circuit is working. It's usually under 20 milliamps, so 4 milliamps is okay. Next we check if there's voltage on the center pin of the clear BIOS header. 2.6 volts is okay, and I just noticed the headed jumper is missing. I'll replace it with a spare jumper. You can check if the crystal is working by putting it on frequency, and this one reads 32.75 kHz. You can reseat the BIOS in case the pins are oxidized and it's not making contact. Next we can check the 5 volt standby that's always on when the power supply is connected, and seeing if that power gets to the chipset and the supervisor IC. At our supervisor IC we have 2 parts. The first one has no part in the pop-up box, so that's not fitted. We look at this one, it's 4.7k resistor, and the other side is connected to standby 5 volts. And we've got 5 volts. At our chipset we have a linear regulator with 1 pin always on the 5 volt standby, and if we go to its output it says 3 volt standby. And we have 3.4 volts. Because I don't know what I'm doing, I did the brain dead thing and started checking random passives all over the board for double shorts. I checked all the passives around the supervisor, then all around the chipset, then all around this random chip, and that's where I found some passives that look like they're double shorted. I could justify the double short over here by tracing the parts, but this capacitor I couldn't. And when you trace it, it goes to the chip. So I removed the cap, but the pad still buzzed. So I checked this chip on my other ASRock, and even though it's a different part, it had double shorts on a couple of passives too, which is probably normal. This is where I started thinking logically and tracing voltages on power rails. I started up the motherboard and checked the auxiliary 12 volts, and I was getting 12 volts to these highlighted parts. I went through the inductor and was getting 12 volts on all these points as well. Then I went for the graphic card voltages. I checked the 12 volts and it was present. I checked the 3.3 volt line and it was okay. And I checked the 3.3 volt auxiliary and it was there. Next I started thinking, I've got power coming into my MOSFETs, but maybe they're blown and nothing's coming out. So I checked the resistance between all the pins of all of them, and they seemed okay. And that's when I thought I'd better check the actual output voltages, because maybe the control chips are blown and they're not turning them on and off. The usual place to check the voltage is at the inductors, and there's 10 of them. This one is 1.6 volts, 5.2 volts, 12.1 volts, another 12.1, 1 volt over here. This one seems dead. This one also looks dead. This one's dead, dead, and dead. Looks like lack of voltage on the rails is the problem. We have no power on this pin of the inductor, and the thing's not blown, so this pin is where it comes in. And it's this MOSFET that's switching through the power. MOSFETs are like remote switches. You supply a small voltage to a pin and it switches and connects the major power pins together. Think of it as like a relay. There is 2 types of MOSFET, the NPN or N channel, which grounds a powered circuit to make it work, sometimes called low side switching, and the PNP or P channel that switches power to the circuit. That's called high side switching. This pin is ground, so it's NPN switching to ground. So this must be the pin the activation signal goes to. That connects to a 10k resistor to ground, so that's a pull down. But the other is a 2 ohm resistor, and that goes to this chip over here. These 2 inductors have no voltage, and it's connected to these 2 MOSFETs. This one is connected to these 2 MOSFETs, and all 4 of them are switched on by this IC over here. But if you go to these 3 dead power rails, these 2 MOSFETs are controlled by this chip, these 2 are controlled by this chip, and this one by this chip. It seems unusual for 3 blown chips, so I'll look for something in common. This is where I started wondering if we're missing a common power supply to these 3 chips. So I started checking linear regulators. This linear regulator has 5 volts standby on this pin and 3 volts standby on this pin. We see 5 volts on the 5 volt standby and 3 volts on the 3 volt standby. This one is 5 volts on pin 3 and 3 volts on pin 2. And it shows 5 volts on pin 3 and 3 volts on pin 2. This is 12 volts on pin 3 and 7 volts on pin 2. And we see our 12 volts and our 7 volt. We can check the 1.05 volts to our chipset and our 3 volts to our BIOS chip. 1.05 and 3.3. All those voltages seemed okay, so I wondered if the 3 chips are connected together. And if you click on pin 2, it goes to the 0 ohm resistor, and if you click on that, it lights up the chip that controls the other MOSFETs, and it's the same when you click on pin 2 of the other chip. It goes 0 ohm resistor and back down to this chip again. The question now, is this chip controlling all our missing rails, and is it dead? Or is there some supervisor telling it not to turn on? Just to be sure, I thought I'd better check these chips if they're actually getting voltage. If we check the datasheet for this high current MOSFET driver, we can see the power come in on pin 4 and 5. If we look at pin 4.5 on this MOSFET driver, it goes through a 2 ohm resistor and over to this double diode. This double diode feeds at 5 volt standby all the time on this pin, but when the power supply starts up, it feeds at 12 volts on this pin. And if we follow that, we get a 2 ohm resistor and then on to the other MOSFET driver. The lower one is reading 11.8 and the upper is reading 12.07 volts when it's running. Next we have our third chip. This is a digitally controlled dual PWM. And this one says VCC5 down here and VCC12 over here. VCC5 says operative voltage is connected to 5 volt filtered. And VCC12 says 7 volt supply. We'll check VCC5 over here. VCC5 seems okay at 5 volts. And we'll check VCC12 on this pin. And VCC12 is showing 7.1 volts. One thing I don't like is that this chip gets hot. Like it's sinking a bit of current. So is this sink faulty? It's kind of hitting 40 when my fingers alone only hit 25. So I started looking at data sheets to see if the supervisor is connected to the dual PWM. Motherboards are an accumulation of individual circuits connected together, and if you find a data sheet for a chip, they usually cut and paste a typical circuit onto it. You can see the MOSFETs that it's directly controlling and these high current drivers that are controlling these other MOSFETs. The problem is, I'm not smart enough to work out if the two are connected from the data sheets. So that's where I'm going to have to go to the dumb approach and just change chips on the board until it works. So I got the microscope out and started taking photo of the chips to get their numbers, and that's when I noticed this under the T. And if you get the light just right, you can see a crack in the chip. Well, we definitely know this chip is rooted. Then to top that off, I started inspecting the motherboard, and if you look at this PCI slot, the pins are nicely in order. But if you look at this other one, they're all mangled and broken and all over the place. Now I have to work out how to change it out without a desoldering gun. This is where the video lives up to its name, because after this, there was no way of fixing it. I was going to try to break up the connector and desolder each pin one by one, but then I saw a video where a guy removed one on a hot plate, so I figured maybe I can get it out with hot air. So I clamped it with something heavy, like vice grips, and hoped it would fall out on its own, and started heating. I wasn't getting anywhere, so I added some flux, which aids in heat transfer, and it eventually came out. I was probably alright up till then, but then I thought I'd better clear out the holes while it was still hot. But when you got a brown motherboard with brown flux on it, it's hard to see it browning when it's burning. Plus when you're working from above pushing the solder blobs out, you can't see under the hot air gun and that it's burning the board. And this is the aftermath. The board delaminated and cracked and took 4 traces with it. This totally sucks because the chips are nearly here and now I've got an unrepairable motherboard. My original idea of pulling the housing off was probably a better idea, because the pins aren't held that tightly in the housing, and that way you could probably just use a soldering iron to remove the pins from the board. I hate watching repair videos that fail, and I reckon all these videos should be burnt. But this was 1 month of work of trying to figure out what was going wrong, and filming and editing it at the same time. Basically it was a truckload of work doing the first 7 minutes of this video, and that means the steaming pile is going to get uploaded no matter what, even though the board is a total write-off. The score so far is 1 working ASRock, 1 totally dead ASRock and 1 totally dead MSI, and an ASUS that I'm still working on because I'm waiting for parts. On a side note, I mentioned a 5th motherboard at the start of this video, and it's a working ASUS B85ME 4th generation Intel that I got through AliExpress, and I coupled that to an i5 4590. Speed-wise, I can't tell the difference between this i5 4th gen and my old i7 3770 3rd gen. But then again, this is only a home theatre PC for my TV, meaning it only has to watch videos and play YouTube, so it's not being pushed at all. But what I did notice was wall power consumption. I originally had an i7 960 1st generation Intel, and I used to see highs of 155 watts and lows of 85 watts. Then when I got my 3rd gen Intel, before it blew up, I was happy to note it only used 65 watts playing YouTube videos. But now that I've got my 4th gen Intel, I notice it's only using 45 watts. And now I kind of don't want to go back to 3rd generation because it uses more power. I'm kind of on a power kick these days to reduce electricity bills, So I got rid of my old 2007 CFL TV that used 170 watts and replaced it with an 80 watt LED, and got rid of that old first gen Intel PC that used about 130 watts and got this 45 watt 4th generation. So that's about a 180 watt saving from the old setup. Sorry about the dud video, but I thought I really was going to fix this one. But I totally butchered it in the end.